Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us first understand the key concept here. When an alkyne is treated with H2 2 moles over PT catalyst, the triple bond is fully hydrogenated to give an alkene. The question asks which alkyne gives an optically inactive alkane product. For a compound to be optically inactive, it must either 1. Have no chiral center, or 2. Have a chiral center but be a meso compound, internal plane of symmetry, or 3. Be a racemic mixture, but since hydrogenation of an achiral alkyne gives a single achiral product in this context, we focus on symmetry. Moving on to the next step. Identify the alkane products after adding 2 moles of H2. A. 3-methyl-1-pentyne CHCCH, CH3, CH2CH3. After adding to H2, CH3, CH2CH, CH3, CH2CH3 is equal to 3-methylpentane. In 3-methylpentane, C3 has CH3, CH2CH3, CH2CH3, H. The two CH2CH3 groups are identical, so C3 is not a chiral center. Therefore, 3-methylpentane has no chiral center and is optically inactive. B. 4-methyl-1-hexyne HCCCH2CH, CH3, CH2CH3. After adding to H2, CH3, CH2CH2CH, CH3, CH2CH3 is equal to 4-methylhexane. C4 has CH3, CH2CH3, CH2CH2CH3, H. All 4 groups are different, so C4 is a chiral center. This compound is optically active. C. 3-methyl-1-heptyne HCCCH, CH3, CH2CH2CH2CH3. After adding to H2, CH3, CH2CH, CH3, CH2CH2CH2CH3 is equal to 3-methylheptane. C3 has CH3, CH2CH3, CH2CH2CH2CH3, H. All 4 groups are different, so C3 is a chiral center. This compound is optically active. Moving on to the next step. Both 4-methylhexane and 3-methylheptane poses a true chiral carbon with 4 different substituents, making them optically active. And for the final step. Option A gives 3-methylpentane, where C3 bears 2 identical ethyl groups, so it is not a chiral center. The molecule is symmetric and optically inactive. Therefore, the correct answer is A. Therefore, the correct answer is option A.